This content is brought to you by Mazunder Academy.
Hello everyone. Today we are going to study about functions in R. So first of all, we will know how to define a function in R. Then we will study about built-in function, user-defined function, then applications of function, how can we apply function for some particular task, then evaluation of algebraic function, some algebraic function, how can we evaluate, that we will study, then graphing math function, and some activity and exercise question. So without further delay, let us start the demonstration. So at the very beginning, what is function? The most easy way to define a function is a self-contained subprogram. Different types of function in R: built-in function and user-defined function. So there are different functions available already in R, which no need to code, just we can simply use them. And if we want to make our own function according to our requirement, so that we can do, that is called user-defined function. So let us see first built-in function. As in the name itself, built-in function in R are predefined function that are available in R programming language to perform some task or operation. Examples of built-in functions, say sum function, min function, max function. Then these are some sort of math functions. Then if we go into statistical functions, then mean function, then variance function, then standard deviation function, histogram. Similarly, there are many more functions available for statistics. Then there are some other types of functions, say table function, which is used to make frequency distribution of a given data, plot function used for graph, then sequence function is used to generate any sequence of values, etc. There are many more functions we will see, and some of them already we are aware. And how to use them we have seen with example in our previous lectures. So without further delay, we will directly jump into the main aim of this lecture, that is user-defined function. So what is user-defined function? Writing our own function to accomplish a particular task. What is the syntax of user-defined function? So syntax is name of the function, okay, some name we will give for the function, and then the keyword function. Function is the keyword that will create the function, and arguments are the parameter that we will pass while creating the function. During the actual function call, these arguments will be replaced by the actual values. And then bracket start here, and within the curly braces you will write the body of the function or statement, and then close the braces. There is another notion of this user-defined function. Sometimes if you want to define a function in one line, that is called inline function. So that syntax also similar: function name, then the keyword function, and then arguments, whatever arguments you have, and then simply the body, provided only one line body here. That's why there is no braces required. If you have multiple lines, then you must give the brackets. Let us see an example. John earns a basic salary of $4,000 per month. He also receives a house rent allowance HRA of 20% of basic and transport allowance TA of 8% of basic. Additionally, he receives a monthly bonus of $500. Calculate his monthly gross salary. And of course, the gross salary will be basic plus HRA plus TA plus any extra amount or bonus. So to write the program, first, bonus is a fixed quantity, so we kept it in a variable say bonus. Then this calculation of the gross salary, we defined a function whose name is gross. Gross is the name of the function and function is the keyword, and this function, all the calculation is depending on the amount of basic salary. Every calculation you can see 20% of basics, 8% of basic. So main parameter is the basic. If basic changes, all calculation will change accordingly. So we kept basic as an argument whose value will be given during the function call. So inside the body of the function gross, we kept a variable say HRA, and how the HRA will be calculated: basic amount multiply by 0.2, that is 20% of the basic. Similarly, TA is another calculation whose calculation will be done basic multiply 0.08, that is 8% of the basic. And then finally, what this gross function will return, it will return the basic amount plus HRA plus TA plus bonus. This all together it will return to the variable to whom it will be assigned. And then for the output, we have used cat function slash, and of course it is for the new line. So gross salary will be what? Gross 4,000, because 4,000 is the basic mentioned in the question here. So basic salary will be passed as an argument, actual argument here, while the function gross is called here. And then if you run, we can see the gross salary, it will result as 5,620. So this is one of the use where function can be used to calculate. It is not necessary to use function. We can solve this, we can write the code without using function also. But if you write function, what is the benefit? Every time when you will call, we can make it dynamic. Suppose if the basic of some other employee, instead of 4,000 it is say 5,000, then what will be the gross salary? Automatically the gross function will calculate and give us when we pass 5,000 as an argument here. So that is the benefit of using function. Next we will see evaluation of algebraic function. If you have an algebraic function like f of x equal to 3x power 2 minus 4x minus 10, we want to write a R program to evaluate f of 3. Then we want to draw a graph of this function. Many times we need to do this task. So let us see. With the help of function, we can accomplish this work very easily. So f is the name of the function we have defined, and function is the keyword, x is the formal argument. Then inside the body we are telling what? Return us 3 multiply whatever the argument, that actual argument will be passed, square of this, and then minus 4 multiply the actual argument minus 10. Now for example here, when you will pass the argument 3, so all x will be replaced by 3. Now let us see question number 1, evaluate f of 3. So the value of f of 3 is, f is the name of the function, and then the argument in place of x we pass the actual argument as 3. And if we run these lines of code, we will get our answer as, you can see in the output, value of f of 3 is 5, and using calculator also you can check it. Second part of the question is draw a graph of the function. So how can we draw the graph of the function? To draw the graph, as we know, we need some x values. So there is a function called plot. So inside the plot, what is the parameter? The function name, the user defined function that we have defined for that for this particular task. So that function we will pass here as the first argument. Then this is the range of values of x from x equal to -5 to 5, and n equal to 300. This is the parameter which will divide this x values into 300 equal parts. -5 to 5, these values will be divided into 300 parts. As much as this n value is bigger, we will get our curve more accurate. Then xlab, another parameter. Xlab is used for any statement or any text if you want to display along x-axis. So I want to display along x-axis values of x. Similarly, I want to display along y-axis values of y. So ylab is the one which can be used for displaying any text along y-axis. Main is the object which can be used for writing any name about the graph. So it will be displayed above the graph. Then color is the one which will be used for giving color to the graph, COL. So if I show you one by one, say for example, if I run this now, we can see the graph here without any labeling, nothing. Okay. Now one by one I will add and show you how it will affect. Say for example, if we run this, then you will see what will happen. So you can see here the values of x, it came along x-axis. Similarly, if we add this ylab in this piece of code, then it will come along y-axis. So you can see here values of y along y-axis, values of x along x-axis. If I add this piece of code main, then it will be added on the above. We can see here graph of the quadratic function, it has come. And if we want to see any color here, then we can give the color here. So you can see if you run, so we have preferred red color here, we have assigned red color, so the graph become red color. So this is the way we can use function to plot our graph of the algebraic function. Another example, I have just write the code here. Write a R program to draw the graph of the function f of x equal to mod x, absolute value function. So simple, first I have defined the function f2 and returned abs of x. So abs means it is the absolute value of x. And there is a function called curve. Curve is a function, it is a part of R graphics package. So instead of plot function here that I have used for the graph, you can use curve function also. So what is the syntax? Curve and then function, whatever the function you want to draw the graph, then x value from where to where, and then similar, you can, this add equal to true you can ignore now, I will explain you what is this. And then simply xlab, ylab, then main and color, everything you can already we have seen in the previous discussion. So if you run it, you can, sorry, we did not run this f2, so first f2 then curve. So you can see the absolute value function here. Now if I add this, the code that I have deleted, say for example, let me remove this. Yes, so for example, the first one, this is the output for the previous graph. And now if I add this, say add equal to true, add equal to true. In that case, what will happen when you run this graph will be displayed along with the previous graph. So you can see it will not be displayed as a new graph. So if you run it, so you can see in the MODEX graph is appearing on the same plane where the previous graph is there. So sometimes we need to compare some of the functions output, so we can use this parameter add equal to true. So in that case, both the curve will be shown in the same xy plane, otherwise it will be shown in two different planes. Similarly, the graph of exponential function, if we want to draw, so this is the one. So for example, if I here also if I add, say add equal to true, first you have to run F3 and then curve. So we can see the new graph for exponential function also attached with the previous two graphs because of add equal to t. And if we remove add equal to t, then the graph of this exponential function will be displayed as a separate new graph. So if I just remove them and if I run them again, then we can see a new graph appeared here, and the previous graph you can see it is here, and this one is the new graph which is alone because add equal to true I have removed. These are some of the activities we can assign to the viewers. You can try, and if you need any support for solving this, you can contact me. So that's all for today's lecture. Thank you so much.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.